My name is Anton Kril. I'm Director of Architecture for Magento. People ask me what I do. Mostly draw diagrams and answer emails. Sometimes write some code, but it's probably maybe 10% of my time. But yes, today I'll be talking about the future of Magento as we see it. Right? By my type of job, I kind of live in future of Magento because my local branches, my local development environment has lots of improvements to Magento that I sometimes forget whether it's already merged in develop or whether it was already released or not. Recently, I remember I saw someone on Twitter complain about non-informative error message, and I was like, come on, we already fixed it and released it, and then I checked it, and it's all in my branch. I just forgot to send a patch. So yeah, when I do development, if I see stupid error message that is not informative, I'll go and fix it. So like, it's great pleasure for me to work with my local branch of Magento. If there is an error, it tells me everything. And by the way, also caches are cleared automatically on my instance. So, but yeah, I'll mention that. So okay, so I'll be talking about future, how we see it, and how we plan to get to that future. Right? Before talking about future, I'll tell you. Let's just recollect what we have today. By the way, so this is a link to an article that I published called Service Isolation. It's a central article of this huge project we call Service Isolation that we are working on right now, and there are more sub design documents to this document. You can go there, you can read all of the content and even more than I'll present today. By the way, also check out the repository, architecture repository. Ramadas earlier today mentioned it. All of the design discussions, Magento design discussions are public now and they happen on this repository. Okay, so this is what we have today. This is at least how I imagine Magento in my head, right? So we have browser side, admin front end, storefront front end, right? And we have server side. Server side is modular. We expose today HTTP server side rendered UI and REST APIs. Behind those REST APIs and server side rendered content, we have modular code. So we have modules like catalog, checkout, sales, customer, wish list. We have these modules, right? And we group those modules by open source edition, commerce edition, B2B edition, right? And whenever you install an instance of Magento, you just get a bunch of those modules, install them together on top of Magento framework, and you have Magento instance. That is a Magento instance, a bunch of modules installed together. On top of them, you install some extensions and do your customizations, right? It's all very good, nice, 2007 style PHP LAMP stack application, right? Monolithic, where we have single database, PHP monolithic code base. You deploy it together as a single application. Easy to deploy, somewhat easy to work with, not as easy to scale, and not that easy to work the more complicated application becomes. Okay. With Magento 2, we started some decoupling. So we allow you now to extract checkout and order management databases from main database to allow them to scale independently. Okay, so you knew about this feature, right? Hopefully, great. By the way, just a check of audience. So who here is a developer? Nice. Okay, who here is a front-end developer? Okay, no, it's very popular in India, but okay, go. So yeah, that's great, because most of it will be about server side. So you're in the right audience. So this is Magento 2. Magento 2 with the ability to to extract some databases for independent scaling. With modular code base, you can install additional modules, remove modules, disable modules. But the problem is that they are coupled so that you cannot deploy separate services independently, right? You can only deploy them together because they do they are kind of modular, but really they are so coupled that most of the modules you cannot remove or disable because Magento will break without them, right? So now, next diagram, I told you I'm drawing diagram mostly, is about big picture of Magento future, how we see it, right? As a company, not just Magento Commerce, the product that most of you know it, right? By the way, it might be not publicly shareable, but okay. So here we have Magento instance on our cloud. By the way, you know we have cloud product, right? Everybody likes cloud. If you host your merchants on cloud, you have a lot more love from Magento than if you host it yourself or on some other hosting. So on cloud, it's our PaaS platform that allows you to deploy Magento instances, right? You can also deploy them not on cloud, but cloud is much better, as I said. And our desire is to offer a lot more services as SaaS multi-tenant services. Why we want to do that? Because it's easier to upgrade clients who use these services. Like, for example, we have order management today. Everybody knows about order management. Great product, SaaS multi-tenant product that offers you more and better order management capabilities than built-in Magento order management, right? So we are releasing Amazon sales channels integration. We have MBI. We're releasing Google Ads channels integrations. All of those are multi-tenant SaaS products, right? So we adding more and more products that are SaaS that Magento works with. Magento is multi-tenant, single-tenant application that works with our multi-tenant SaaS services, right? So that's where we want to go. We still want to keep our commerce open source with our huge community and ecosystem, but also offer more services, hosted SaaS, multi-tenant services. To do that, we need to have strict interfaces that we can share between Magento Commerce and the SaaS services. And this pushes us to decouple application. This is one of the reasons why we want to do that. Other reason is we want to, you see on this diagram, by the way, Vinay, did you take my clicker? Oh, sorry, I blamed Vinay already. Here I am. Okay, so you see on this diagram that Magento doesn't work. Okay, so Magento is deployed as a set of instances that talk. And some of the instances, some of the services can be replaced by SaaS service. So it will be a bit more clear on. Come on. A bit more clear on this diagram, where we want to. This is the main idea of service isolation project, where you take separate services like catalog, checkout, order management, and you have them isolated, and you can deploy them independently. You can upgrade them independently. The benefits of that, as I said, is that first there is strict contracts between services. So you can, for example, take and replace a single tenant built-in Magento catalog with a hosted multi-tenant SaaS catalog that Magento offers or someone else offers. Clear contracts, no illegal communication between modules, not through service contracts. Right? Second benefit is that you can deploy them independently and scale them independently. Right? You can upgrade them independently. So all of these benefits for distributed. I'm not calling it microservices. I'm calling it isolated services, that's where you have application deployed as a set of independent services that you can upgrade and deploy independently. I repeated it so many times; it should be pretty clear by now what we want to do, right? And as you can see, every service here has a separate database, right? Because it's a rule of how you build microservices. If you want your services to be independent, every service has to have separate data storage. So here we would be continuing the work that we started in Magento 2, where we isolated checkout and order management databases to allow them to deploy them separately. Couple more interesting things on this diagram, at least one. The first interesting is that there is React here. So this is PWA Studio and Venia that we are working on, and we are releasing the first version of it with 2.3.1. So it will be first huge step to this decoupling, where we decouple backend from frontend. Where front-end application is written in JavaScript, in React, you can write it independently, and you are isolated from backend by APIs, right? So this is very important, very huge, and it's already, we are already releasing first iteration of this product, right? Great. So other thing that to note here is upward. So this is a backend for frontend. It's an application, very lightweight application that actually allows you to define these APIs that connect your Magento instance to your PWA Studio, PWA application. Read about it on our design, on our architecture repository. It's a very simple thing, but the huge benefit it gives you is that if you're a front-end developer, you do not need an instance of backend instance of Magento installed on your machine. You can just work with your JavaScript application that works with an upward implementation. Nice? So you can fake all of those APIs. Okay, great. One more important thing here to notice on this diagram is the CQRS concept application, where we have catalog and we have catalog query, where we have data storage or service where merchant authors contents and product information. And we have data storage from which the storefront APIs read data. And we already have it in Magento. And it's implemented with indexation, because you write your raw data to source tables, and then you read that data from index tables, and indexation aggregates the data, right? So we want to move further and further in that direction. And in this specific example, the catalog query where we are already moving, and you might not have noticed it, but there is work by performance team where we add, and performance and import team, where we add more data to Elasticsearch index, where at some point Elasticsearch index becomes the source of truth for storefront. Okay, does it make sense? People, okay, good. Give me some feedback. It should be more, I have to understand if you get me, if you understand me. So this is huge, also huge. Like Elasticsearch becomes your source of truth for reading data on storefront. And what it allows you to do, again, your write data storage is optimized for writes. Your read data storage is optimized for what? For reads. Right. So this is like top level, high level explanation of what we do and of what we plan to do. But now I'll go into more details. It will become more boring. But yes, okay. So this project is very huge. Right, and it will require a lot of movements in a lot of directions. It's actually multiple different projects, because you cannot just, I should have put the meme here, you cannot just get and distribute your Magento instance. You need to do a lot of things before it, right? So these are the things that I will be talking about. And first, and the most complicated of them, probably the most complicated, is distributed communication, right? Who worked with microservice architectures here before? A bunch of, right? So you probably, people who worked with microservices know that it's hard. Right? Am I right? Yes, I'm right. Of course I'm right. Why is it hard? Because a network is a scary place. Network, for a person, network, so there was a question about, right before I came to the stage, there was a question about why does Varnish cache empty content? Because of this. Because of timeouts, right? So there was a timeout. Timeouts were not set up. There was a connection timeout. Varnish cached empty content, right? So, and timeouts happen, right? Unlike in process communication, when you have a function A call function B, and you always know that function B exists unless a meteorite kills your AWS instance and all life on planet, that function B will be there in process. right? And it will respond, and you will get that response from that function B. And with network, it's a lot less reliable. And you have timeouts, you have some router or switch hang packets, or it filters the packets or something. Just connection is a lot less stable. So you have to resolve lots and lots of problems with the connection. And it's of course, it was of course described long time ago before me in form of, it's a known famous article about fallacies of of distributed computing, right? So many people who come from in-process communication to inter-process communication or inter-machine communication, network communication, they bring with them some assumptions from simple programs to distributed programs that don't hold, right? And it's a lot harder to work with distributed programs. So we have to take all of that into account. So one of the solutions we think about, so when you enter this problem, you enter the problem of timeouts, of lost connections, of hanged connections. Actually, when a server is down, it's not the worst scenario. When you have a service A, like checkout, doing a call to catalog to retrieve product data. When a catalog is down, it's not the worst case. The worst case is when catalog is up, but it's very slow. Right, it will be eating all of your connections. For that, as a counter to that, you have circuit breakers, you have all of the different patterns that you will read about in books like Building Microservices, if you haven't read those books before. But the important thing is that people thought about these problems before us, and they've solved all of those problems. Well, not completely, but yeah, kind of. Partly, they resolve the problems, and one of the solutions to that is called service mesh, where you have a separate layer for communication between your services. It's a separate application that sits on a container with your application, and you use it for communication. And it abstracts away all of the problems with network, like lost connections, hang connections, retries. If a server you are trying to talk to is under huge load, it will stop loading it with more connections and stuff like that. Make sense? Who knows who heard about service mesh before? Okay. Now you heard about it, you'll come home and you'll read more about it, it'll be good. It's a nice thing. So how actually we plan to have communication between checkout and catalog, for example? What do we need to do for that? First, we need an API between them. Right? And we already have that API. That API is called service contracts in Magento 2, right? Who knows what service contracts are? Everybody knows what service contracts are, it's great. So we have catalog module, we have catalog service contracts, we call them catalog APIs. So what do we need to do, distributed communication between those two services, is we have to install this API on two services. So catalog API should be installed on catalog service and on checkout service. It's kind of counterintuitive. Why do you install API on catalog API on checkout? But checkout has to know the API it can use, right? Okay, so that's, at least so far, that's our design, how two services communicate. But here is one interesting thing already you can see here, that you have three types of code base here. So you have checkout, forget about checkout. You have catalog API. You have catalog proxy that implements this API but only calls the remote service. Right? And then you have real catalog implementation. But today it's all single code base, right? It's all single module. And you cannot extract API to install it here. It all goes with catalog implementation. That's how we come to problem of code modularity and more granular module structure that we need. Can you see it? Okay, so today we see that catalog is a single folder, a single composer package, single Magento folder, and it contains all of the code base for catalog. Blocks, controllers, web API declarations, configurations, implementation, APIs, everything is there, event observers. So with this distributed model, we would like to separate it. Why we want to separate it? Because we want to put catalog API on multiple services. We want to put catalog implementation only on catalog service. We want to put catalog UI only on UI service, right? So that's a huge thing we have to do. To first improve granularity of modules. And the good news is that can be done as a non-breaking change. Right? You just extract folders, call a folder catalog API, move interfaces from catalog to that folder, and just use composer magic to route namespaces to new folder. And for extensions, namespaces stay the same. It just different modules. Smart, very smart. Okay. So next thing. So this was okay. I'll stop a bit on this more because it's important. The nice thing here is that if you have a catalog service, you will only have catalog API, catalog web API on it. You don't need all the bloat of all the other modules. Your service becomes much lighter. Cool. Okay, just wanted to mention that, sorry. So next point, is it clear so far? Cool. So next thing is service design. It's a separate, like, you start to distribute your modules. So what do you need to do? As I said, you need to define APIs. And there are some rules to define APIs. Because, as I said also, we are already in distributed world, where we do not have not only our code is distributed, our data is distributed. We do not, in distributed world, you do not have benefit of transactions, right? When you have multiple databases, and you do the calls to multiple services, you do not have transactions built into database. You have to think about how will you implement your application without transactions. You have to think how your services will communicate to each other. What are the best practices for the services? What happens if an operation timed out? Can I repeat that operation? Or if I repeat that operation, if I call the service to add product to cart, right? I'm adding product to cart or placing order, right? And then something happened. My server went down. AWS killed it. What should I do? I should probably retry it. But is the operation of placing order retriable? We don't know. It might be not retriable. You might place two orders. You might charge a customer twice. Right? So you have to take that all into account. And with that in mind, one of the big problems is data consistency. Right? Who heard about CAP theorem? Please, come on. I mean, I know more of you, but okay, good. So CAP theorem, it's a very, very old theorem that says that between consistency, availability, and partition tolerance, you can only choose two, right? 2 out of 3. So consistency is when you write to database, like if you have multiple instances, all of them are immediately consistent to whoever you wrote a value, and you can read the same value from any instance the next moment in time. Availability is that if one instance goes down, you still can retrieve data. Partition tolerance is that you can split effectively data. But the problem today is that in modern world and the way how applications should be architected today, and they all should be architected in the distributed manner, partition tolerance is not an option anymore. It's a requirement. Because if you have multiple data storages, they have to be partitioning tolerant. So you can only choose between consistency and availability, right? So consistency is rarely required in 90% of cases and scenarios. Full consistency is not required. So for most scenarios, you can choose eventually consistent applications. So okay, I will not ask that question, but eventual consistent data storages, eventually consistent communication allows you to have to improve scalability of your application significantly. Why? Because your services, you do not have a promise of full consistency. You do not need extra communication to check. Okay, did you get this data from me between services? Are you consistent with me? Are you consistent with me? You don't have this promise of consistency. You can say, okay, so you added this product to catalog. We will show it to you in 5 seconds. Okay, and this removal of this important allows you to scale your application much better. So again, I spent a lot of time here, but that's important thing. So we will be choosing eventual consistency more. And that's just one of the design principles that we've came up so far. Eventual consistency. Other is all operations must be idempotent. So idempotence, for those who don't know, is it means effectively it means repeatability of operation. So it doesn't matter how many times you call an operation, it will give you visually same results. Right? So place order operation is called idempotent if no matter how many times you call this operation with same arguments, you'll always get only single order placed. Right? By design, all get operations in HTTP, as Vinay mentioned, are idempotent. So you can ask for products many times, you will always retrieve the same set of products. But write operations are more complex. Why idempotence is important in distributed applications? Because again, network is a scary place. You can lose your connection, you can lose your call, and you might need to retry it. So every operation has to be retriable. Nice? Nice. There must be no data dependency. So I already mentioned it. It's microservice design. Services should be deployable independently, so they should not use single data store. They should use separate data storages. Sagas, again, it's a bit more for those who don't need, are not involved in microservice design. Sagas is just one of the patterns how you manage this consistency of data communication between services. And asynchronous APIs. We don't like synchronous APIs anymore. We like asynchronous APIs. Why do we like asynchronous APIs? Because asynchronous APIs allow you to decouple your services not only in place. Microservices allow you to decouple your code in place, but asynchronous APIs allow you to decouple your services in time. So you call the service A, call the service B, and it doesn't care when the service B will respond, because API is asynchronous. Something is happening over there. But, okay, command query I already mentioned. We want to separate command APIs from query APIs. Why? Because you can optimize command APIs for writes, you can optimize query APIs for reads. Compare swap. One thing that Magento never thought about is concurrency issues. And in some rare scenarios, you can find a bunch of issues with concurrency in Magento today. With distributed model, these issues will be happening more often, and we have to think how we resolve these concurrency issues. Like two processes do something concurrently, and then one hanged, and the other is doing something, and then the first one came back up and is trying to do the same thing, and they both rewrite each other. Mess. So we have to solve how do we do that. And for now, a solution that we want to use is compare and swap tokens. You'll read about them if you don't know what they are. Don't worry about these terms. Nothing complex about it, just things. So next, so those are design principles, but also if you, other important thing is framework. If you want to have multiple applications communicate to each other, every application should be much lighter than it is today, than Magento is today, right? It should be very lightweight. So as I showed before on modularity on granular service modules, your services will already be more lighter because they will not need a lot of modules that you install today. But you also will have a lighter framework. How can you achieve that? So how does request processing work today? So do we do a check? Like, who knows how Magento processes requests, or do I just tell you quickly? I just tell you quickly. Okay, so we have index PHP, then we have index PHP calls Bootstrap, then Bootstrap calls, the important thing is that Bootstrap loads global configuration, like di.xml from etc folder, right? So it loads object manager and stuff. Then we have application HTTP class that does area routing. It checks from request which area is currently loaded. Is it admin, is it web API, is it storefront? And then it was loud. But then depending on which area was loaded, it loads additional configurations. We already see waste we load configuration twice. First global, then front end. We have some optimizations there, but by design, application loads it twice. Next, for storefront scenario, storefront application, storefront front controller is loaded, storefront front controller, but it's loaded, right? And then it does its additional routing. Then it defines which action controller was defined. Action controller calls some service contract to retrieve some data from it, and then it tries to render it on server with our view infrastructure, layouts, blocks, and all that stuff. If during routing we define that we are web API, we go to web API front controller, then web API front controller finds a service contract to call, calls the service contracts, and that's it. So you can already see that in this distributed model, where if you have a checkout service, you don't need all of that branch because you don't render on server. You only have web API. So you don't need storefront front controller, you don't have action controllers, you don't need to call service contracts, and you don't need view. Also, what we can do by having an entry point per area, you can avoid this intermediate step of area loading and just load area immediately, right? Does it make sense? Of course it makes sense. So how an optimized workflow would look? You have your entry point per area, you do some bootstrap, you load your area configuration, only one step of loading configuration. Then front controller that does routing for a specific service contract and just call service contract, right? On diagrams, this looks much lighter. Good. So there is a lot more things that we need to do to framework, and we already have a prototype. I published it, where we implemented a lot of things that allow you to do it, like no store loading, automated cache invalidation, only single the configuration is loaded only once, no is installed checks, it's stupid to have them in application. Store resolving is optional for some services, only services that know about stores should know about store resolving. Application classes, I told you, we killed them because we don't need area resolving. Much lighter request response classes because they request and response classes load too many dependencies. No layout, no URL rewrite, and no all of this stuff that you don't need. In checkout service, if you just serve web API requests, you don't need layout. That's the benefit of an isolated application. One more thing, I already published the design, is no registration PHP files. Yoo-hoo! Who likes them? I think I like them, but that's a separate conversation. And much more that we are doing with framework to make it lighter. Again, follow our architecture repository. We are publishing documents, designs there. I think tomorrow I'll publish one more proposal on how to repurpose app folder from a module folder to have like a module-less application, where you write your code in your app folder and you don't need a module for that. And you use app etc similar to how you use etc in the module folder. Okay, so follow it, try to take a look at that, and I'll publish that proposal. Very important for us to get your feedback. Now DevOps, very important thing. If you have your application, a distributed application, how do you manage it? It's much harder to manage multiple instances of application than a single monolithic application. So our solution for that, at least for now, is to use unified platform. For today, unified platform is Docker, Kubernetes. So my local instance is Minikube. It's a local instance of Kubernetes. I play with it. We are working on a more shareable, publicly shareable instance of Kubernetes for DevBox. Take a look at that. Why Kubernetes? We just discussed it. Because Kubernetes, every cloud platform talks Kubernetes now. You have Kubernetes on Amazon, EKS, you have Kubernetes on Azure, you have on Google Cloud platform. Cool? Cool. So by having your instance of Magento and all your services deployed on your local instance, one more important thing, on your local machine, you can have same configuration as you have on production, with all of the services deployed separately, right? Now, another important aspect that we are thinking about, again, I'm just telling you all of these problems that we encounter and we have to solve, and we are solving, and how we plan to solve them. But this problem will not appear with distributed model, it already exists today. So you are an SI, a developer, work for system integrator, right? Most of you are, I assume. And now you have a problem. You have 5 instances of Magento for 5 clients. Now you want to flush cache or run indexation on one of the instances. What do you have to do today? You have to SSH to that instance and run flush cache or run indexation or some administrative process. Not good, right? SSH is not the best. It's not the best practice to have give SSH access to production instances to clients. So what we are working on is an administrative tool that allows you to connect. So you have it on local machine. You connect it to instances, different instances. It might be different instances, distributed instances of single installation, or it might be multiple different clients. So you just say, I have a new instance, context add, call it checkout, and now it connects to that instance and collects from it the commands that you can execute on that instance. And now running the command on your local machine, it will send those commands to that instance. Good? Nice. Okay, so this project, you can follow this project here on this repository. You can contribute to that. As always, we are a very open source company. Please do that. Testing. So you have all of these services. How do you test them? This is very early discussion, but this diagram effectively shows how we can get close to SaaS-like upgrade experience for our cloud customers. We are now unifying, Magento is working on unifying testing, so this pictogram means testing, CI/CD, where whenever an extension vendor uploads new extension to Marketplace, or a community member publishes commit to our GitHub, we run some tests. Today we run them differently for different part of application. We want to unify that. Okay, so we will unify it. We are building this testing service that will run tests on demand. You just tell it, okay, run this test on this version of Magento with this extensions installed. So we are doing that to automatically test extensions, contributions, and stuff like that. But next thing that we are also doing, we plan to work on, is adding testing to cloud. So who uses Magento Cloud here? That's good, great. So if you used it, you know that today you're probably missing ability to run functional tests automatically on commit. With this addition, whenever you commit something, a functional test, Magento core functional tests are run against your commit. Why is this important for you? Because it gets you close to automatic upgrades. And with MFTF, Magento Functional Testing Framework, you know that you can leverage Magento core test suite, the functional tests that Magento runs itself, to run those tests against your client instance. But you will ask me, okay, but I replaced checkout on my client instance. Your checkout test will fail. And I will tell you, that's why we have Magento Functional Testing Framework. It's customizable the same way as Magento is customizable. If you replace checkout, you can go and replace test steps in every scenario that uses checkout. You can replace the steps in a non-conflicting way. It's a pretty unique thing, and many people don't understand it about Magento Functional Testing Framework, that it's a pretty unique framework that allows customization, because testing people usually don't think about customizations. And we could not find such framework, so we had to build one. Okay, so this is MFTF. And yeah, one more important thing. Again, this is all discussions designed for now, but we are thinking of adding capacity and performance testing capabilities to our functional testing framework. Because you already described the scenarios, right? Why copy the description of scenarios to your performance testing framework if you already describe scenarios in functional testing framework? Cool. One more cool thing. Now, release process. If you look about all of this complexity, of how many things we need to release, you understand that our current release process is not very good for that, because we have these big bang releases of huge Magento, like 2.1, 2.2, 2.3. These are huge releases. Right? So what we are doing already, we started it with B2B, then we continued with MSI and Page Builder, independent releases. And that is how we plan to move with modularity releases. When we have 2.3.1, at some point we release new module, new version, new service of checkout. Then we iterate it a couple times, release new versions, and then when we are ready, we just include it with the next minor release or next patch release of Magento core instance. So it was released independently, separately from Magento application. So some people, if you want to use newer version, you can go and upgrade to this newer version. But then when we release new version of whole Magento, not just this service, you'll be able to automatically upgrade to the service. Good? Great. And this is an important thing that will allow us to do these huge changes gradually over next couple of years in a not very conflicting and bad way with these big bang releases. Okay, so I talked a lot. Overall goal of this, like the things that we plan to do. So I rushed through all of these projects, all of these decisions we have to make. Like you understand that it's a pretty big list of things that we have to do, right? What is the main goal of it? I wrote it down here, you can read it, but that's a very important thing for me. We have to provide our merchants and SIs, you guys, with a platform that will allow them to evolve iterations in an agile way. So you get a client, if I ever start an agency, my motto will be, we will have you in production in 2 weeks. With the simplest scenario possible, but you will have your store in production, and then I would iterate you by adding more and more features to your store. Of course, reality might change my dreams, but I think this is very important to have a platform that will allow you to do it. To gradually evolve your client's instance, where you deployed your instance and then you evolve checkout separately, catalog separately, by adding new features. So this thing, I believe, this set of changes will allow you to do it much easier. Okay, so that was it. Please go read this article. Please go, if you want to follow me, you can use this Twitter handle. And I'm done. Thank you. Okay, so do we have any questions?
Do we have the separate databases for catalog and catalog query?
So here, with our simplistic understanding of current, we will be iterating over this design. Yes, these are separate databases because this is MySQL and this is Elastic.
But it has same data, like same SKU.
Yes, same SKUs, but their data is aggregated with prices, stock, inventory, is everything you need for very quick search. Does it make sense?
So it's kind of read-only in the catalog query?
Could you repeat that?
It's a read-only for catalog query?
Yes, live catalog, but eventually consistent. Same as catalog data is already eventually consistent today, because you need to wait for there is still some period for indexation that you need today, but we'll just be embracing this approach and we're following this approach to have this separation. What will it allow us to do is to have very quick queries for search and aggregation of data.
So it's kind of optimization for reading?
Yes.
That's the only purpose, okay?
Yes, optimize for reading and optimize for search. One more question. Can you? Yeah.
We are using Magento Cloud, and from your lecture, we understand that the catalog query and catalog has a separate data, like one for Elasticsearch. It is a built-in functionality provided by Magento with Magento Cloud. So can you please explain how do you make consistency between two databases? Because we are facing one issue many times, whenever we are using catalog search, Elasticsearch result and category navigation count, layer count, both are not matching. So this ticket is already open from our side in Magento, and so is it basic root cause for that incidents?
What's the root cause for that issue? If your question is what's the root cause for that issue, I don't know. I mean, but that specific, I would have to take a look at that issue. And yes, there are problems today. That's one of the things that we need to do here, and that's one of the things what we want to do, is that this process of data aggregation, it's not finalized yet. We have index dependencies. We have one index that aggregates data to one table, then another index reads data from that table and aggregates to different table, and then writes to. Because of that, because of the complexity of this process today, there are some bugs with it. There is a field for bugs. But with simplification and removal, aggregation some of the indexes to simpler indexations, by saying that this is the source of truth now, and this is a separate service that aggregates data in single indexation process, we plan to eliminate field for bugs. Not eliminate, but reduce the field for bugs by simplifying this process. So yes, again, the indexation will be eventually consistent, but the plan is to, I would say that indexation, today's Magento indexation was done gradually over time and was not very well designed thing. Because indexes were, the first index was added, then second, and the third, and then it grew to this complex system of indexation in Magento with dependencies between indexes. So what we have to do now is to redesign this, not completely redesign, but review the system, take a look what we can optimize, what indexes we can combine, and that's how we hope to eliminate some bugs.
And one more thing is that as of policies of Magento Cloud, they are taking a snapshot on every 6 hours as per policies. So whenever Magento Cloud is taking backup snapshot, then whole of the distributed system database will be a snapshot, or particular databases will be only a snapshot?
Well, my quick answer to you now, because I'm an architect, I can just give you quick answers. Yes, we will make it work for all databases. Okay. More complicated answer will be yes, we will have to do it for more databases. Yes, it will have to work for all databases.
And
but it's very easy for me to answer. But by the design, one of the requirements, we are cloud first company. So for now, the policy of Magento is that if it does not work on cloud, it does not work. We like every new project, every new feature that we release, and you will see that it has to work on cloud. By the way, the PWA Studio, one of the reasons why it was a bit delayed over some date that we had, because we had to make it work on cloud by default, out of the box.
And for the architecture overview, Magento recommend with Magento 2 when it released, Magento application should should not use a share hosting. So whenever we are purchasing a cloud, then why other environments like a development environments, rather than staging and production, you are providing on one shared hosting? What is the reason behind that?
Well, it's a bit out of scope of this talk, but pricing, right, and cost. But one more important thing that I just realized that I forgot to mention is that this distributed model, only bigger clients will benefit from this. So the requirement now is to support both models. A monolithic model, as you have today, just to have more strict service contracts between modules and have them more isolated, to have better modularity and easier, easier for you to, if you don't need some module, to disable it or remove it. Like on the flight here, I just realized, I think I saw dependencies that customer depends on wishlist today, which is crazy. Why a customer module depends on wishlist? So we are removing all those dependencies. But you will still, what I'm trying to say, you will still benefit from this isolation and modularity, even if you distribute in a monolithic manner, in a monolithic way. And most of you will still be doing that. Yes, there is a mic.
You showed us the relation between checkout and the catalog module. So will we be in a position to use the external inventory management software, and we will only use the checkout module of the Magento? We will use some external CRM for customers, and only checkout, we will be only using the checkout module of the Magento, and other things will be from the external systems.
So if I understand the question correctly, the fact that checkout is isolated here, so out of the box, Magento will be using checkout APIs, but it will be much easier than today to implement a proxy implementation of checkout that will go to some different service, right?
Yes, the catalog inventory management. The catalog management is some external system, like the inventory management, where the products are stored.
Product what?
Products are stored. SKUs are stored.
Okay, yeah.
That is kind of an external system. That is a centralized system.
Yeah.
So can we use that kind of integration?
Well, everything is possible. What I'm trying to say is that out of the box, we don't plan to support it, but it will be much easier to implement such substitution with the distributed model. But data store, it will be current data store, it would be isolated, more isolated, if I answer correctly.
Yeah, in the same way, like for the customer, we are using some external CRM module, and we want to host our customers there only.
Yeah.
And we will be using only checkout module of the Magento. We can do it?
Yeah, exactly. So that's the point. Because your customer is isolated, it's much easier to replace it than today. Because today you have all of the illegal dependencies. It's very hard to replace customer because like checkout calls some low-level model from customer today. The main work that we'll have to do is to eliminate those dependencies and only communicate to APIs. And when you have communication only through APIs, you can replace implementation of those APIs. Okay, couple more questions. I don't know how good we are with time. By the way, I'm holding you from lunch. So I don't know.
Yeah, hi Anton, I have a question. Yeah. So you said that Magento is moving towards, is actually focusing more on Magento Cloud, right?
Yeah. I mean, sorry.
So as an architect, if I have to ask, if for an on-premise installation, what would you recommend, AWS or Azure for Magento Commerce on-premise?
Okay. What I would recommend is containerized environment of Magento. AWS gives you a very convenient way of working with containerized environments. Azure gives you a very convenient way of working with containerized environments. Google Cloud. So I would recommend any cloud computing platform that allows you to work with your application in a modern way, with containers that you don't have SSH access to. If it misbehaves, you just kill it and redistribute it. You know this concept, old term, cattle versus pets. The service, your services, your instances, you should treat them as cattle. So if they misbehave, you don't give them names, you just give them numbers, and if you need to redeploy something, you just kill the old service and you deploy a new instance. How you can do that? If your instance of Magento is containerized and deployed in the environment that understands containers. So for me, this environment is Kubernetes. Very easy to work with containers. You can deploy many instances of Magento, many versions on single virtual machine that I have on my local computer. So I would recommend any platform that allows you an easy work with containerized environment, plus very important thing is CI/CD pipeline.
Okay, thank you.
Okay, guys, thank you. Bye.